and we are ready to begin. I'm going to batter through chapter 6, and I've got pretty much all the questions here. I've even left the answers in. That's just going to make it easier for everyone. And so what I'm going to do is I'm going to read the question and maybe justify their answer. And it's all that terminology, you know, retrospective studies, prospective studies, double-blind experiments, right? All those things we've been talking about for days now. So a teacher wants to determine how class attendance during the term affects their grades. Describe how the data would be collected in a prospective observational study. Well, prospective means you collect the data right from now and onwards. So when they say the teacher will record attendance data throughout the term, right? Attendance on Monday, attendance on Tuesday, and that would be it. If you wanted to do it as a retrospective study, wouldn't you wait until the end of the term and then just collect the data then? So that would be an example of it. So she's not collecting it as it happens. She collects the data after it's happened, right? So the quarter's finished and now she collects the data. Now I give one disadvantage for collecting the data this way. And the one that they've got is student behavior might be altered if they find out the teacher is keeping attendance records. Oh, I never thought of that. If your teacher never used to, and then Monday she takes attendance and Tuesday takes attendance, couldn't that affect attendance? People tend to change the behavior if they are knowing, if it is known they're being observed. Give it a different example. Suppose you worked for the council or the county, and the county wanted to know what speeds cars were doing in certain streets. And what you did is you get two guys with stopwatches, right, and a board. And as cars go by, they click a little thing and they get a little speed thing, a little speed gun, and they write it down, right? What happens when drivers drive along that road and they see somebody with a speed gun and a card and writing stuff down? Doesn't it tend to make them slow down? So the act of measuring can distort your data. Won't you then think, oh, that street's not that bad, everybody's doing 30. Well, if you weren't there or you hid behind a bush, couldn't they all be doing 40s? It's only the fact that they see you distorts it. So that's a kind of example of what I think they're getting at in C. And in this one here, although it's not clear, they say that one of the disadvantages of collecting it at the end is that students may not accurately remember or report their attendance. So it looks like I should have read up there. It's the students at the end of the quarter. You say to them, how many days were you off? And they say, I think I was off 3 times, or was it 4, right? They're not good at remembering. I would also add to that, wouldn't they maybe lie? Right? I was truant 8 times, but since she's asking me, she doesn't know. So can't I just say it's 4 times and it won't look so bad when my parents find out? You know, that's an example. Right, this one here I'm going to read all the way through so I don't screw up. Students whose undergraduate major was economics were followed for a whole 10 years after their graduation. And they looked at the number of different jobs they took for, whatever reason. So majors in economics, how many different jobs they had over a 10-year period, right? This is a retrospective study. No. Aren't you following them throughout the years, right? It's not you waited to the end of 10 years and then look backwards. Well, that one, if you phrased it a little bit clearer, I think would have been easier to understand. Students who had meningitis were matched with students who hadn't. On gender, undergraduate or graduate status in college. Students' recent activities were examined to discover the risk factors for meningitis. Okay, so they basically looked at people who had meningitis and they looked at people who didn't have it, and then they looked at various things that they did. I don't think they need to mention all this stuff here, except it might be important. Maybe males get meningitis more than females. Maybe people who are at college or undergraduates do it differently. But that is a retrospective study, right? They've already caught meningitis, and now they're going to try and figure out what are the common features that people who do have meningitis have compared to those who don't. And so I have no idea if there's any connection. Isn't meningitis contagious? And so all you need to do is catch it off someone else. I think in Britain, it might be called this in America. Isn't that called the kissing disease?
Mono.
Is it? So it's a different one, right? But anyway, not meningitis, but there's another.
Is like teeth, isn't it? Like
yes, it's swelling of the brain. It's not very good. Can kill you.
So what's the definition between the two? Prospective and retrospective.
Prospective, right? A prospective study would be, right now you're interested in something and you're going to follow them for the next 10 years. So it's looking into the future, following them into the future. That is a prospective study, right? Retro, right, past. A retrospective study would be, it's already happened, right? Today is the day that you start looking at your data, but the data has already happened, right? Because it's 10 years ago that they caught it, or they've already caught meningitis and now you're going to find out what it's like, right? So if you already know the information and you're just looking back into the past to figure it out, retro, you're getting the information from the past. Prospective, you're going to get the information, but you have to wait to the future. So it'll be things like you follow them for 10 years would be a good sentence to make you think prospective. Retrospective would be, a lot of people have caught meningitis. Now we're going to look into what kind of things made them catch it, right? What kind of common factors?
Thank you.
Now, a medical researcher wants to know how lifetime sun exposure affects the risk of skin cancer for people over 50 years old. And then it says, describe how data might be collected in a retrospective case study. So you're going to gather a sample of people who are over 50 who have skin cancer, and you find a sample of 50 people who do not have skin cancer, right? So you have two groups. Now, you didn't make them go out in the sun, right? They did that, right? And they got skin cancer, or they got it because whatever reason they got it. But you've got 50 people with skin cancer and 50 who've not. Then what you do is you find out things about them, like, where did you live? And if a lot of people with skin cancer lived in places with lots of sunshine, and a lot of the people who didn't have skin cancer didn't live in places that had lots of sunshine, wouldn't sunshine be a pretty strong cause of skin cancer? Right? Skin cancer in Scotland is very, very rare. Skin cancer, I'll make it up. Skin cancer in Arizona or California, wouldn't that be much higher? What is the connecting factor? The connecting factor here is not lifestyle. It's not that you're rich or poor. It's not to do with the food you eat. Cancers can be caused by what you eat as well, right? Wouldn't the predominant factor be access to sunshine, right? Sun causes skin cancer. The major cause of it is skin cancer. You could even isolate that. Couldn't you find people in California whose job was to work outside all the time, and other people whose job was in the office, right? They both live in California, but wouldn't the outside people probably have higher skin cancer rates than the inside office people? Because you're outside in the sun, right? So that would be another way to convince you that you've homed in on the major cause. Many times don't diseases have lots of causes, but there's probably one major, right? 90% of the people catch it because of this. And then there's things like, well, a common reason to catch cancer is genetics. If you have anybody in your family, let's say with breast cancer, you should be really careful about getting checked, because that is a very genetic prone disease, right? Other things are out with your control, like sunshine, right? You can live in a sunny place or not, but you can't control your genetics, right? Your mom and dad gave you those. And so that would be a different cause. Lots of diseases are triggered by an environmental effect. So you're okay until you get in contact with a particular weed killer. And then you end up with liver cancer because your kidneys don't like the chemicals in the thing. And there I go and drift, but it's good to know stuff. So Reuters reported, this is fine, on a study published in the Journal of the American Medical Association. That is a high prestige journal. There's one in Britain called The Lancet. That's a very high prestige. Anything that goes on The Lancet or the American Medical Association is treated almost like gospel, right? Because they don't publish it unless it's been like verified 3 times by really clever people. So they came up with this, and they recruited, in this story, 276 volunteers and used nose drops to affect them with a cold virus. Ooh, you're pushing ethics there, right? You're deliberately giving people the cold, essentially. The volunteers, well, I guess volunteering gets you around it a little bit, were then quarantined and observed to see whether they came down with a cold or infection. They also answered questions about their social lives, including the number of different contacts they had and so on. And Reuters reported that those with up to 3 types of social contacts were 4 times as likely to come down with cold symptoms and signs of infection compared to those with 6 or more contacts. So they give you the cold virus, but that doesn't necessarily mean then that you get the cold. Doesn't your immune system sometimes kill it before you get it? That's why we have an immune system, right? Before COVID came around, didn't some of you catch the flu and some of you didn't? And then next year you catch it and somebody didn't. The chances are that all of you got the flu virus. In other words, it was around you and it entered your body. But didn't some of your antibodies say, you ain't getting in here, and they killed it straight dead, and others got through? So evidently what that is telling us is that the more people you mix with, social contacts, the less chance you have of coming down with the flu. So let me try and, they've got their answer. Let me try and find out why that's the case. That's their answer, is that one. Okay, here's a story. If you hang about a lot of people, won't you be exposed to lots of germs and viruses? Because people have them. And if you have a lot of exposure, won't your immune system probably be better? Yeah, that's my evidence. How could I back that up? Do you know, you might not like it, but do you know if you have lots of kiddies, do you know the best thing you can do for their later health up to a point is let them mix with lots of kids and catch the germs that the little kiddies give each other, in which case your little kid, your little Joey is going to be sniffling for a couple of years, but won't they have an awful lot of different antibodies and be quite good immune systems? If you take little Joey and you're frightened about him catching illnesses, and let's say there's no underlying condition like heart disease and you don't want them to catch it because it would kill them, isn't the chances are that that poor little Joey is going to catch everything under the sun? So I'll share one more story with you. I was, when I first started teaching, I caught every flu, cold, bug you could name for about the first 3 years. I was a medical mess. I was sniffling, coughing, everything. And the reason for that is that in my job, before COVID came at least, aren't you in very close contact with a lot of people? In my office, in my classroom, and whatever, right? And so my immune system got a bit of a shock, and I caught everything under the sun. But see, after the 3 years, I very rarely caught anything. My immune system was so blinking good. You could have gave me the plague and I wouldn't have caught it. I mean, I was that good an immune system. Now, as I get older, my immune system's not as great, and I'm going to blame COVID for this. I have been stuck in this room. See, once I start teaching this coming fall in Bremerton, in a building, I am probably going to catch every bloody cold and flu for the next 2 years, just in time to retire and have a good immune system again. So let's see what they're talking about here in this one. You can read those ones. Right, explain why it's preferable, whenever possible, to do a randomized experiment rather than observational studies. A randomized experiment always gives you good evidence of cause and effect, because aren't the two groups essentially like each other, except for one thing? And so any differences that you detect was caused by that one thing. That's what makes it so good, right? Some get the good, some get the pill, some get the placebo, right? Everything else is the same. So if there's an improvement, it's the pill that did it. A headline in a major newspaper read, breastfed youth found to do better in school. Interesting. Now, do you think this statement is based on observation or an experiment? What's the most likely?
Observation.
I would think so. Oh God, it's there in front of you. I forgot the answers there. It's an observational study, yes.
I would say, no, I was going to say because partly because generally there's a lot more observational studies and newspapers like to hype up results.
Yes, and isn't by its very nature, aren't observational studies very dodgy when you put a conclusion of A causes B, right? Because of that confounding variable thing. Well, I'll hide this one so there's no answers to bother us. Why I would be able to argue that that's not true, that feeding your baby with mother's milk is going to be making a difference to the child's later school academic performance. And here's just an argument of a confounding variable. Mothers who breastfed their babies may well be, not all of them, but a large proportion of those. Couldn't they also be mothers that stay at home and are with their kids a lot? And not only do they do that, they sing to them, they read to them, you know, they interact with them. And don't all those things tend to make a child's development faster and better? And so all you're really reflecting in is the fact that a mother who spends a lot of time with quality time with their child is probably going to have an effect on that child's performance later on. That would be a confounding variable, right? The mum doesn't need to feed the baby. Couldn't the mum just stay at home and do everything else? And that child would probably still do better at school. A lot of the studies that they've done here are not connected with that. They did a study, and the government did a study. I don't know if I can remember what city it was. Anyway, it was a study that had a lot of educational problems caused by the poverty of the parent. Mostly it was single parent families. And so what they did is that they provided like pre-school. In other words, you could take your baby, like a 12-month-old baby, and they gave it lots of stimulus, right? They did a lot of attention to that baby and see if you could make that help, you know, get the child a kind of extra start, right? A little push into the school system so that when they entered kindergarten, then went on to normal school, they had a kind of start, right? And they found out that it did make an improvement for the first couple of years. So the children in their kindergarten, and then they went on to, you know, first and second grade, they did get a good start, but after that, it kind of leveled off. So it doesn't make a permanent distance, at least the one I read, didn't make a permanent thing. And here is a study called the Hawthorne effect. So I'll let you read that, and now you know what the Hawthorne effect is. Question 10. An investigator believes that the new medication will help to reduce anxiety and that a placebo will not. Okay, giving somebody a sugar pill shouldn't change how anxious you feel. Now, it's in a single blind study. Now, a single blind study means that the person who's getting the pill doesn't know if they're getting a real, you know, reduce my anxiety pill or just a sugar pill, a placebo. The result is that the group taking the new medication had reduced anxiety while the placebo group did not. Explain how the experimenter effect may have played a role in this. That's interesting. That's not the way I thought that question was going to go. If you don't tell the person that the pill that they're getting is the sugar pill, the placebo, then the placebo effect will take place. That person, if they believe it, will feel less anxious, right? And so you will be able to detect that there was a reduction. The pill that was designed for it will have a big reduction in anxiety, but won't the placebo very often have a small reduction in anxiety? So the reason that small reduction disappeared, and they said the experimenter effect is, I suspect they're getting at here is that the experimenter was actually the person collecting the data. It wasn't a doctor that didn't know what was going on. And the experimenter was subconsciously indicating to the placebo people that they had a placebo. You're really anxious. They have that concerned voice. I can't do concerned voices, but they have that concerned voice. Don't you pick up the concerned voice, right? And then you can pick up the optimistic voice. Oh, how's your anxiety going now? You know, a bit better, you know, that upbeat voice. Well, don't people pick up on cues like that? And, you know, that transfers into the data. Which is why you try and do it a double blind. Don't you remove the experimenter from collecting the data and you give it to a doctor, you know, that person's doctor. And then you don't tell the doctor what they're getting. Do you see how that removes everything from the equation? And so you get much cleaner data. Now, an experimenter on an elephant in captivity was done. And what they did is they wanted to see where you could get elephants, would they breed more often if the male and female elephant were part of a herd, or if you just isolated the male and female, right, and put them in a separate area on their own. And it wouldn't surprise me if one of those increased the pregnancy rate, right? So you get more baby elephants out of it. And then they explain how ecological validity establishes that. Elephants will behave different in captivity than they do in the wild. Right, they just do. So it might work in a zoo, but that's not reality for an elephant out in the wild, right? And so you might say, oh, well, elephants breed much better when there are only two elephants, right? And the other elephants aren't around, right? When we proved that because in a zoo, we got more pregnancies when we did that. Well, out in the wild, two elephants don't go off on their own. Isn't that a kind of dangerous thing for any animal to do? Right? When you're in a herd, you've got protection. So it's not transferable to the real life world. A retrospective study of 517 veterans who never smoked was done to see if there were other things that might have been causing the fact they got cancer, right? And they did things like, well, did you work in areas where there was a lot of bad gases, right? Or dust or fumes? What am I thinking of? If you're in a tank, isn't there a great chance there's probably some really yucky fumes going on, unless it's a really modern tank, right? for example, right? Something like that. And a concern expressed by the investigators was that, in this study, the veterans were asked whether or not they remember being exposed to those things. Memory is a very dangerous thing. Don't you only remember what you want to remember or what seems significant to you, right? And what they found out, and this is their concern, is it was expressed by the investigators that the patients who have history of lung disease were more likely to recall being exposed to horrible gases or smells or whatever, and whether it was accurate or not, and then subjects reporting good health. Right, if you've got good health, you don't remember maybe as often things like that. And when you got cancer, I'm assuming what they're getting at is you think back and say, I wonder how I caught that. And then you think, yeah, I spent 6 months in the truck shop repairing diesel engines. And that was a really horrible place. There were a lot of weird smells going on. And I was breathing in, carbon dioxide off those diesel trucks all the time. And they remember that. But if you don't have cancer, yeah, I worked with trucks and I worked with this and I worked with, it doesn't strike you as being significant. And they say yes. Let's see what their yes is. Relying on memory, yes. So discuss whether each of the following is likely to be a problem. Relying on the memory, yes. Participants who may not have a good memory of lifelong exposure may also be inclined to create memories or exposures if they had lung cancer. So even if you don't remember it, sometimes you kind of believe that you remember incidences that may or may not have happened. Confounding variable, there's a choice, and there's that Hawthorne effect that we know. This one's going to be a nice easy one. Decide whether the experiment or effect is more likely to be a problem in a study that is double blind, single blind, or not blind. It's going to be a problem if it's not blind. Actually, if you are going to be the person collecting the data, it's going to cause a problem. This is remember this one, this is a little bit complicated in my brain at least. 22 grocery stores will participate in an experiment to compare the effectiveness of 2 ways to display a product. The response variable will be the number of items of the product sold during a week. So let's suppose that you're putting a push on cornflakes. And one way of displaying them is put them right at the front door when you come in and have a big pile of cornflakes, right? And, blah, blah, 82 cents. And how would the other one work? I don't know where the other one is. You have a big poster right in the middle with lights on, blinking, saying, get your cornflakes here. I don't know, right? 2 different ways of doing it. Now, if you wanted to do a completely randomized design for this, you would have to take the 22 stores and break them into 11 stores each, right? And then assign a different one, right? So what you would do, you take 22 stores and you'd randomly break them into 2 11s. And you say to the first 11 stores, put your cornflakes at the front door. And you say to the other 11, do the big flashy light poster thingy that I said. And then you would collect data on how many each store sold in cornflakes. Okay, I can do that. Now, if you're doing a matched pair design, that's a little bit sophisticated. You've got 22 stores. One of the problems with stores are they aren't all the same size and shape. Some are little mom and pop stores, right? Where there are only like 3 kinds of cornflakes if you're lucky. And some are super Walmarts, right? And where you can have a whole row of cornflakes, right? So you're not really comparing like with like. So if you did a match pair, what you would try and do is take your 22 stores and pair them off. So 2 stores were pretty like each other, right? That's a mom and pop in, a little town. This is another mom and pop in a different little town. And those 2 could be compared. and one of them gets put it at the front door and the other gets the other. Now, if you match them up, so it'd be, I'm assuming 11 pairs, right? Couldn't you then compare the difference in selling? Because since there's only 22, couldn't you be really unlucky and have a lot of big stores in the second group? So don't big stores sell a lot more cornflakes than little stores? And so you might not be able to tell the difference. So that's quite a subtle tweak to the idea. Oh, 15. Vitamin C. Right, before we begin, show off. I am, there we go, a great believer in vitamin C. I haven't seen good evidence that I should be a great believer in vitamin C, but nonetheless, it's probably the placebo effect, but I think it's good for me, so I take them. So 20 students agreed to participate in a study on colds. 10 were randomly assigned to receive vitamin C. The other 10 got something that just tasted and looked like a vitamin C tablet, right? But it just had sugar in it. Oh, haven't they done the first part of a double blind? You don't know if you're getting vitamin C or not, do you? The student did not know whether, I'll just repeat that, but the investigator did, i.e. the guy collecting the data did know. That's bad news. The students were evaluated after 2 months to see how many caught the cold and how many didn't. Explain whether each of the following terms applies to this experiment. Was there a placebo? Yes. Wasn't there a sugar pill in this story? Is it single blind? Yes. The people getting the pill didn't know what they were getting. Is it double blind? No. Wasn't it the researcher who was collecting the data? Didn't he know who was getting C and who wasn't, right? So that's why it's single. Was it a matched pair? No. Matched pairs are really good. Twins, identical twins are loved by the pharmaceutical companies. If you're an identical twin, you could probably almost make a living by just volunteering for various paid pharmaceutical experiments. What's great about identical twins is genetically, aren't they almost identical? And isn't that a perfect match pair world? Can you imagine you give one of them vitamin C and the other you don't? They live together. Well, we'll assume that we're talking, identical twins that are, young enough to still live together, right? And they do pretty much everything else together, right? A lot of twins do. So at the end of the day, aren't matched pair quite useful? Because it gives you really good data with very small data sets. This is not matched pair. Repeated measures. Well, this one didn't have a repeated measure. A repeated measure would be that whatever you did, let's do an experiment where it would be a repeated measure. You wanted to find out if drinking alcohol impaired your coordination, right? A quick way of doing that is, do you know they have a light and you press a button when you see the light? If you're totally sober, I think reaction time's about 1/10 of a second, right? When you see the light and you press a button, it takes your body about 1/10 of a second to react, right? If you take alcohol, it might take you 2/10 of a second. That's why you should never drink or drive, right? Your reactions are much slower. Your observational skills are really short. Hence, don't drink and drive, right? Now, a repeated measure would be, you take Maggie and you do an experiment and you give her 5 glasses of whiskey and she did the thing. And then she comes in tomorrow and we do it again. And then she comes in for 4 weeks and she does it again. She's an alcoholic by the end of that 4 weeks, but haven't we repeated the experiment lots of times? Right, that's a repeated experiment, right? And I think in this case, didn't you just give them the vitamin C and that was it, right? It's like a 1-dose deal. And replication, right? Well, you did it to 2 groups, so yes. Okay, I've got 8 minutes to finish this. I think we'll do it. 20 volunteers in that age group participated in an experiment to compare two methods of memorizing information. The age variation in the participants concerned the researchers because memorizing skills will decrease with age. That's true. Describe how the study could be done using a matched pair design. So what you would do here is, if you've only got a small group of people and you want to get the best data, sometimes you have to resort to this matched pair. So you'd get two people who are 60 something, right? And two people who are about 55 or, you know, give or take a year, and two 15, 16-year-olds, right? So you had one of each group, one in one group and the other in the other group. And then the one would be given this method to memorize things and the other would be given the second method. And then you could average them out. Now, if you do that, can you see that you've found a way to separate a very small group so that the groups are very similar to each other as age distribution goes, right? You've got young and young. If you just did it randomly and there's only 20 of them, couldn't you have a lot more older in one group than the other? And wouldn't that distort your data because of that? That one's too long. I'll let you read it. It's a good one, but it's too long. This one's much shorter. In the following experiment, decide whether a control group was used and whether a placebo was used. Right, so you have two groups. One's called a control group, right? They're the ones that typically would get the placebo, or if they don't get the placebo, those are the ones that you compare your other group to, right? So one is the control and the other's called the experimental group. An electric company wanted to know whether residential customers would use less electricity during the peak hours if they were charged more for those hours. Sneaky. 100 customers were randomly selected to receive the special time of the day rates. So you went and told them, if you use it during these times, I'm going to cost that, $10. But if you use it during these off-peak times, we'll only charge you $5, right? So they're kind of given the information right up front when they could do what they and what they would get charged. And they were matched with 100 customers who were similar in terms in the past usage. So we've got two different groups here. Haven't we got like a matched pair situation? Almost a matched pair at least. We've got two groups. Special meters were installed, and then at the end of the 3 months, they figured out how much was compared to each pair, right? So we got compare. Now, this definitely had a control group. And the control group wasn't that the 100 people who weren't told about the deal, right? They just used their electricity as always. And the other group, the experimental group, got it. Now, if they found out that when you do that deal, right, when you make that happen, people use off-peak electricity more, then that would be an incentive for them to do it, because electricity is expensive to produce, and it's much better if it's flat. The electricity isn't flat. During the night, most of us hardly use any electricity, right? And then you get up in the morning and, and then in the evening you make dinner and so it goes up and down and up and down. And those peaks cost electricity companies more money to produce electricity because they have two kinds of electricity. They have like the basic power station that produces, a million gigawatts. And then they have a backup, which is things like hydroelectric, which they only switch on when when there's a big demand, right? They cut it off and then, pull the plug, demand's coming. That's expensive for them. Single blind, let that one go. Oh, last one. Okay, let's finish on the last one then. Researchers want to check to see if a certain type of exercise program will help injured athletes get back to sports. Athletes who had suffered from pulled hamstrings were randomly assigned to two different exercise programs. The first one was yoga and a walking fitness regimen. And after several weeks of participating in the exercise, the athletes were evaluated by medical personnel and cleared to resume activity. And researchers found that those who were assigned to the yoga returned to regular activity in a mean of 2.7 days faster than the walking fitness. So there are two things. You do yoga or you do a lot of walking. And the ones that did yoga recovered in about 2.7 days quicker than the other lot. That's pretty good evidence if that's true. Right? Now, is this a single blind? Why is it single blind? The person who's not knowing what's going on here is not the patient. Don't you know if you're doing yoga and don't you know if you're doing a lot of walking? So you kind of know what treatment you're given. What they didn't mention, or I didn't read there, is that the person who's recording the data, right, wasn't told and was never asked to find out what treatment the person got. So that's where the single blind. The researcher was blind, right? He didn't know which one, right? The data come in, but he didn't know at the beginning what it was. The independent variable here is which exercise program, and the dependent, right, the time required to resume, right? So the x-axis is how long did it take you to recover, and the y-axis was 2 dots. Bit weird, but 2 dots it is. And I am getting really good at this because it's 11:49.